Hi, my name is Jose Villazon, and this is my Physics 2 Lab 2. A little introduction. The purpose of this lab is to compare the electric force from the point charge model of the floating tape from Lab 1 to the electric force produced by the line charge model. Some physics principles we'll be using are the same ones from Lab 1, Newton's second law, Coulomb's law, and the gravitational force. A little small preview of our results. We found that the charge on each tape using the line charge model was 2 times 10 to the minus 8th, and then the electric force was 1.58 times 10 to the negative 3. So the experiment, we did most of the actual data collection and all that in Lab 1, but just a reminder of all the data we got. The system was the top tape, surrounding was the bottom tape. We have the initial conditions for the tapes, each tape's mass, length, width, and area, and also the distance between the tapes when they were not moving and suspended in air. So then, same calculations that we found last time. We found that the magnitude of the electric force was equal to the magnitude of the force of gravity, since F net equals 0. So in using this, we set this equal now differently compared to Lab 1. We set it equal to the electric field of a rod equation times the charge Q. And then solving for Q, we found that the electric charge on one piece of tape using the rod equation was 2 times 10 to the negative 8th coulombs. So for our code, which was the majority of this lab, we have our initial constants. UFPES is the same thing as K, which is 9 times 10 to the 9th, and then gravity, which is 9.81. And then we have the mass of our tape, which we defined earlier, which is 0.0002, and then Q, the new estimated charge Q that we found on the previous slide. Then we defined how to function to find the electric field, which is right here, and it's the same thing that we used again in Lab 1, but this time we used a new function to calculate the line charges. So continuing, then we created creating the top tape and the bottom tape, which is the red and the blue. The top tape being the red one, obviously, and the bottom one being the blue one. And we input the distance between them, which we found in the lab. So yeah, the top tape was 0.02 meters above the bottom tape. And yeah, and so then with these two created, then we can calculate the charge for each small piece dq. Well, each small piece which has a charge dq, and then using these for loops we can add all those tiny pieces dq to get the final charge of the entire line. And then once we found the entire charge of that line, then that allows us to calculate the electric field, which allows us to calculate the magnitude of the electric force, which we found to be 1.58 times 10 to the negative 3. And then you can see here that the electric force pointing upwards, force of gravity pointing downwards, and all the green arrows is the electric field. Some assumptions we made for this lab was that air resistance is negligible, that the charge of each tape is the same, the charge is uniformly distributed on each of the tapes, and some possible sources of error in this lab are that the measurements could have been imprecise and that the tapes might not have had equal charge due to handling of the tapes. So what if you had modeled each of your tapes as a single point charge like in the previous lab? Compare the estimated value of the charge you get when you used your experimental data to produce a point charge model to the value you got with your line charge model. So comparing here in Lab 1, we got that with the point charge model that the charge on each tape was 9.33 times 10 to the negative 9th, but in this lab using the line charge model we got 2 times 10 to the negative 8th. Now, why do these estimates differ, and which value is more likely to be closer to the real value, and why? These estimates differ due to the differing levels of precision in the calculations. The line charge model is more accurate because it uses smaller segments of charge along the tape's length instead of generalizing to a single point. Thank you.